Hello and welcome to this video. In this video we'll talk about SQL Delight, a library that supports Kotlin Multiplatform. My name is Per-Erik, and if you like my videos, please like, subscribe and share my videos. Let's get started. Our starting point in this video is an application. It's just a list showing some items. This specific items is fetched from a repository, which is in memory only, so no persistence. So our goal with this video is to implement SQL Delight and fetch the items from the database instead of in memory. In the common main, under the Kotlin source folder, we have a post feature. In this one, we have a domain where we have defined the post repository interface with the functions that we want to have. We also have the implementation in the data layer, and this is of course an in-memory. We can see all the posts in immutable list together with the implemented functions from the interface. It's basically just some crude functions. We need to add some dependencies. We start by adding the version for SQL Delight, and of course also the libraries needed. We also need the Android startup runtime to make it easy for us to access the Android context. Once this is done, we can close that one down and go into the Compose app module. In the build Gradle, we will now add the needed dependencies. The first thing we need to do is to add the plugin, the SQL Delight plugin. We will also need to add some dependencies to the source sets. Starting in Android, where we need to add the startup. And we also need to add the SQL Delight so we can access the Android driver for SQLDelight. In the common main, we also add some coroutine extensions that is needed. We also need a stately common for the SQL Delight. For iOS, we need to add the native driver. And finally, on the desktop, we need to get the SQLDelight driver as well. Also remember, you need to synchronize the project from time to time, especially when you're working with the Gradle file. The next step is to configure the SQL Delight. We do that in a SQL Delight block at the bottom, at the root in the Gradle build. The package name is very important. It actually defines where your generated data classes will end up. So when you import them, you will have these paths. But you can of course set it to whatever you like. Next step is to open up the Xcode project. There might be some way to do this from the Gradle. I haven't found it yet. If you find it, please leave a comment. But we need to add a flag to the linker so that we can access the database from the iOS side. Select the root folder, and under build settings you can search for linker, and under linking general you will find other linker flags. Double click on it, click on the plus, and then just type -l SQLDelight 3 and press enter. And then we can close down Xcode again. Now we are ready to start with the implementations. In common main, we need to first create a SQL Delight data. So we create a source set. We call it SQL Delight. Under this, we will create the folder, just the same structure as we had in the package name. And of course, you can name it whatever you like. Inside this folder, we will create a new file, an SQ file. I just call it database. You can call it what you prefer. And inside this one, we write the in this we write the SQL code that will create the database. So the first thing, we need to set the user version to 1. This is so that it will become easier for us to upgrade the database later. We also have the create table query, and then I also call this table DTO at the end as a data transfer object, because I will convert them into a post domain object later. So it makes it a little bit easier for me to keep them apart. Then I will have some named queries. The first one is that I wanted to select the last inserted row ID. This is helpful if you want to update some objects without reloading everything. All these functions that we're adding, the name of top followed by the colon is function names that will be generated by the SQL Delight plugin. So we add and we use the most common one. Remember, we need to add SQL queries so that we can implement the interface that we already defined. If we want to pre-fill the database, we can create either inside this file, but I prefer to have a separate file. In this case, I will call it pre-populate. And inside this one, I can just add insert queries to fill the database with the data I would like to have. So I just added 10 items for us to have something to look at. Now we need to start to create the different drivers, and there are different ways to do this. So we will use the actual, expect actual. So first we'll create the driver factory with a function called create driver, and it should return an SQL driver. This one has to be expected. So this is just kind of the definition of this one. We also need a function to create the actual database. It will take this driver factory and return a database. You can see sometimes that you get a lot of errors in Fleet. I think since it's under development, it will become better. It's not always possible to just fix it and insert it. So sometimes I just have to disable and enable smart mode and it starts working again. We can see now that we managed to get the import to work. It might be a little bit tricky from time to time, but it's okay. Let's also add the database name. We also need to have the database name. I'll put it as a value, global value for now. And then we need to start implementing the expected class for all the different targets. Let's start with the iOS, which is actually the simplest one. Create the folder, the same folders as where you put the expected class, and create a new file with the same name. I usually add .ios between the name and the extension just to amplify that this is the iOS implementation. And then let's just create this class. Now let's move on to the Android implementation. We can create the folders again. You can always create both folders just by adding a dash between them. And we create a new file and same name, but we change to .android. And then we implement this one again. So when we are going to create the Android SQL driver, we use the database schema just as before. We also need to add the context here. So, but we don't have a context right now, so we will get back to that one in just a second. Let's change this one into a to-do while we are creating the instantiation class, so we can get the context. Let's create an app context wrapper. The only thing it will contain is the context. It's a singleton. But since it's application context, it doesn't really matter. Let's change so we get this application wrapper dot app context. And we also know that in this case, if it doesn't exist, there's nothing we can do. So we can just add double exclamation mark and crash. Throw a null pointer exception if this would happen. Okay, but it's not initialized, so we need to create an initializer as well. Let's create it as an internal class. Let's call it context initializer, and it will implement the initializer and have the type context. Now we should be able to access the context from the driver factory on Android. Oh, forgot one thing. We also need in the Android manifest to, in the application, add a provider, this initialization provider. And we also need to add the tool definition to get rid of some errors. You can also see here that we actually defined the class that we just implemented. Now we should have access to the context. Now to the desktop main. Same here, create the folders and create the actual implementation of the driver factory. And for this one, I'll also add desktop as a identifier of this file. I waited with the desktop because desktop is a little bit more complex than Android and iOS. There's quite a lot of extra things we need to do to make this work as we want it to be. But let's start with the factory first. We need to have a path to the file, to the database file. So we need to create a function called getPath. I want to be able to change if it's debug or not, because I want to be able to switch that depending if it's a production build or just a debug build. So I'm just preparing for it. I will not use it that much today. I will show how to get a temporary file path and how to get or how to define your own. So we can, if it's debug, we want to have the Java temporary directory. Remember, this is stored between sessions, but it can be deleted whenever the system feels like it. If it's not debug, we will get the user home directory. So let's make sure that the parent folder, the folder where we will put the database, if it exists or not. So let's just get the path by getting the property. And then we will add the folder name we want to put it in. Let's call it SQL Delight demo. If you, for example, want this to be a hidden folder, you can just add dot in front of it. And now we'll create just a file object. So we check if it doesn't exist, let's create it. Make the directories. And after that we will now create a path to the database file, and we will return this path. So now we have our function to get the file path. Now let's create the driver. We can also check here that if the file doesn't exist, we know that the database has not been created yet. So we can create the database based on the schema. And finally, we can just return the created driver. We can also see that you get the warning. We can suppress this one. We get the suppress annotations just to get rid of it. Okay, time to implement the repository for the database to replace our in-memory repository. Okay, the first thing we need to do is to have a data source for our repository. In this case, data source for the SQL database. First, we define the interface that we want this data source to implement. The functions will be mapped one-to-one with the one we have in the repository later on. The only real difference here is that this interface will return data transfer objects, not the domain objects. So the repository will map these DTOs into the domain objects. When we define the interface, it's time to implement a data source using this interface. Let's create post data source SQL, since it's an SQL database we're working with. It will take the database and it will also implement the data source interface. And let's just implement these functions a little bit quick. You can look at the GitHub repository if you having trouble to following my speed run on this one. There we go. We have the data source implemented. Next step would be Next step would be to implement the repository. So let's create a post repository SQL. It will take a data source. And of course also implement the repository interface. The thing we will do here is we will map the post DTOs into the post object. For this we need some help classes. So let's create some extension functions for the post. It's important that this is in the data layer if you're following, for example, clean architecture, so that the references goes in the right direction. So we need two extensions, one to map the post DTO to a post, and one the other way around to map the post to a post DTO object. Now when we have those extension functions, the help functions, we can finish to implement the repository. Hey Google, set an alarm at 7:30 tonight. And now we can just replace the in-memory repository with our repository. And the last thing to do is to remove the in-memory repository and replace it with our post repository SQL to gain access to the database instead. To make sure it works, let's change to discovering Kotlin Multiplatform for the first item so we can see that is actually reading from the database instead. Let's test. Let's start with a desktop application, and we can see it works. Discovering Kotlin Multiplatform. Let's do iOS app. And there we go. We can see that one also have Kotlin Multiplatform, the first one. And then let's go for Android. And we also have Discovering Kotlin Multiplatform as the first item here. So, and that is how we can use SQL Delight. Okay, let's say we want to update our database. We go to the database, SQ file. We start by adding, for example, we want to add the number of views. We need to update the affected queries. We also need to update the post, the domain object. We add the number of views, and then in the conversion we have to, in the helper functions, we need to add the number of views both on to DTO and to the domain object. And then of course in the data source we need to also update the code, the functions to have the number of views. And we also want to have some visual change, so we want to see the number of views in the list. We make it a little bit simpler here. We just put it in the same string as the primary text to make it simple for us. We need to, in the SQL source folder, also add a new folder called migrations. Inside this we will create SQM files, SQL migration files. They have to be named by the version you're upgrading from. So in our case we have version 1, and if the current version is number 1, we will run this file, and we will alter the table by adding a column. We also need to update the user version to 2. In the driver factory for desktop, we still need to do a little bit more. Both Android and iOS can handle the migration automatically, but for the desktop we need to add a little bit more. So first we need a function that can give us the current version. We need to update the memory repository as well if we want to keep it, or delete it if you don't want it anymore. Might be good to keep it for testing purposes. And now we can see it was generated. The default was 0. When we did the migration, we can check it again after we deleted the database, and now we see we get the injected values as well. And for iOS, there we go, 0, because due to the migration. If we delete the application, whoops, and then run it again, we should get the pre-population, which has different views. And let's do the same for Android just to validate that it works. First we should get with all zeros due to the migration. All zeros. And then if we uninstall this application so that we don't do the migration, we run the pre-population, we should see that we have numbers on the items instead. And there we go. Thank you for watching, and remember to hit the like, subscribe button so you get notifications when my next video comes. Happy coding!